Welcome to the best way to clean your coffee maker.
Yeah, I'm really excited to get into this one. It's something everyone deals with.
It really is. Because, right now, deep inside the dark, wet plumbing of your coffee machine, there is a microscopic chemical reaction happening.
It is slowly building a wall of solid rock.
Literally rock.
Yeah,
And it's actively destroying the flavor of your favorite beans.
it's wild because you probably don't even realize it's happening, you know?
Exactly. I mean, you wake up, you stumble into the kitchen on autopilot, hit the brew button, and just wait for that familiar aroma.
Right, that comforting morning smell.
But lately, when you take that first sip, something's just, wow, it's off.
Yeah, a little bitter, a little weird.
And you blame the beans,
Right.
or you blame the tap water. But the truth is much stranger, and it's happening completely out of sight.
It really is.
So today, our mission is to rescue your daily brew from that dreaded funky taste. We're consulting this incredibly practical and, frankly, deeply satisfying YouTube walkthrough from the channel. Clean that up.
Oh, it's a great video. Really breaks it down.
It does. We're
Good.
breaking down their exact protocol to get your machine back to making that pristine cup of coffee you actually deserve.
Because the stakes here are genuinely higher than most people realize.
Yeah, beyond just bad-tasting coffee.
Oh, absolutely.
Yeah.
I mean, we weren't just talking about improving the flavor profile of your morning roast, though obviously, that's the immediate payoff.
Right. Nobody wants a bad cup of coffee.
But what we're really confronting is the gradual, silent degradation of a surprisingly complex appliance. Drawing directly from our source material, the root cause of that bad taste is internal hard water buildup. We are talking about Limescale.
Limescale. The silent killer of appliances.
Exactly. And if you ignore that buildup, you aren't just ruining your drink. You are actively destroying the machine's internal thermodynamics.
Wow. Thermodynamics. That sounds intense for a coffee maker.
It is. Because removing that scale ensures your coffee maker heats up to the precise temperature required for extraction. It runs efficiently, and ultimately it survives years longer before you're forced to just, trash it and buy a new one.
Okay, let's unpack this. Because I think a lot of us just look at our coffee makers as these magic black boxes.
Oh, 100%. Yeah.
We put water and grounds in the top, hot coffee magically dispenses out the bottom, and we deliberately avoid thinking about what's accumulating in the middle.
We really don't want to know.
But the video points out that the very first symptom is that slightly bitter, almost funky flavor. And it creeps up on you.
Yeah, it's not a night and day difference where suddenly your coffee tastes like swamp water.
Right. It's insidious because of how gradual the chemical shift is. You slowly adapt to the worsening taste.
You do. But let's look at the actual chemistry of what's happening when you taste that funk.
I'd love to. Break it down for me.
So coffee is naturally acidic, right? It's full of bright, fruity compounds like chlorogenic acids.
Yeah.
That's what gives a good cup its complex flavor. But Limescale, on the other hand, is highly alkaline.
Oh, so they're opposites.
Exactly. It's primarily composed of calcium carbonate and magnesium that precipitate out of your tap water when it gets heated.
Wait, so you're saying there's an actual acid-base reaction happening while I'm just trying to brew my morning cup?
Precisely. As the fresh, slightly acidic water passes over this thick bed of alkaline limescale inside the heating tubes, it neutralizes the water.
Oh, wow.
Yeah, and when that chemically flattened water hits your coffee grounds, it physically cannot extract those bright, delicate, acidic flavor notes anymore.
Because it's already been neutralized.
Exactly. All it manages to extract are the harsh, bitter, flat compounds. The funky taste is literally the flavor of chemical neutralization.
That is wild. It's not just making the water dirty, it's changing the chemical capacity of the water to extract flavor.
You nailed it.
But it's not just a flavor issue, right? Like when I think about limescale building up inside those tiny internal tubes, it makes me think of putting a thick winter sweater over your machine's heating element.
That's a really good way to visualize it.
Like the machine is trying to push heat into the water, but there's this layer of rock insulating it. It has to work twice as hard, pulling more electricity, getting dangerously hot just to push heat through that sweater.
Yeah, and which means the water probably never even reaches the optimal 200 degrees required to brew good coffee anyway.
Oh, so it's brewing cold. Well, cooler.
Right. That thermodynamic analogy is spot on. Calcium carbonate is a terrible conductor of heat. The internal heating block of your coffee maker is usually made of aluminum. specifically because aluminum transfers heat almost instantly.
Makes sense.
But when you coat that aluminum in a millimeter of rock-hard calcium, the heat transfer plummets.
Wow.
The heating element runs longer and hotter, putting immense thermal stress on the surrounding plastic and electronic components.
So it's slowly cooking itself to death.
Literally. The brewing cycle slows to a crawl, and as you mentioned, the water hitting your beans is ultimately too cool to extract the oils properly.
So you get under-extracted, sour coffee mixed with the bitter neutralization we just talked about.
It's a perfect storm of bad flavor.
So the funky taste is basically an alarm bell.
Yeah, exactly.
And machine is crying out for help before it literally burns itself out. So how do we intervene?
Right. The rescue mission.
Before we go full mad scientist and start pouring chemicals into the reservoir, the Clean That Up video lays out a critical prep phase.
This is so important.
You have to empty the carafe of any old coffee, obviously. But more importantly, you must completely rid the machine of any leftover coffee grounds.
It sounds elementary, but the chemistry dictates why this is mandatory.
Really? I feel like a stray ground wouldn't be a big deal.
Oh, it's a huge deal. If you're about to run a descaling solution, which is, a dedicated acid through this machine, you absolutely cannot have organic matter sitting in the filter basket.
Why not?
Well, coffee beans are packed with complex lipids and oils, specifically compounds called cafestol and coeal.
Okay.
When you hit those old, already extracted grounds with a hot acid, you cause those oils to undergo rapid oxidation.
Oh, no.
You are essentially brewing a highly acidic, rancid batch of chemical coffee.
Okay, just the phrase rancid chemical coffee is enough to make me physically recoil.
I know, it's awful, but it gets worse.
How does it get worse?
Not only does steeping old grounds in acid defeat the purpose of flushing the system, but the acid causes the organic matter to break down into a sludgy, sticky matrix.
Oh, gross.
Yeah, and it coats the inside of your filter housing. You're creating a new, much stickier problem while trying to solve the spale problem.
So you need a completely sterile, neutral starting point.
Exactly.
I want everyone listening right now to just mentally picture their own coffee maker sitting on the counter.
Yep, picture it.
Be honest with yourself. When was the last time you actually checked for rogue grounds hiding in the deep crevices of the basket?
Probably never for most people.
Right. We just dump the paper filter in the trash and call it a day.
Yeah.
But there's always that one clump of wet, oily grounds clinging to the plastic hinge or the spring-loaded drip valve at the bottom.
And we operate these machines in our most groggy, uncaffeinated states. We're on autopilot.
Totally on autopilot.
Breaking that autopilot routine is the first real step. Taking 2 minutes to physically inspect the basket, wipe out those stray clumps, and rinse the carafe ensures that the chemical intervention we're about to introduce focuses entirely on dissolving calcium carbonate.
Rather than fighting a losing battle against oxidized coffee lipids.
Exactly.
Which perfectly sets up the chemical intervention itself. We need an acid to dissolve that alkaline rock sweater, insulating the heating block.
Yes, the heavy artillery.
The source video throws two specific contenders into the ring. The first is the ultimate household staple standard white vinegar.
A classic.
And the second is a specialized commercial product, barkeeper's friend, coffee maker Descaler.
Right. Chemically speaking, both contenders are exploiting the exact same scientific principle.
Okay, explain that.
To dissolve a base like calcium carbonate, you must introduce an acid to donate protons to the base, breaking its molecular bonds.
So it just rips the rock apart.
Yes. White vinegar is a solution of acetic acid. When acetic acid hits limescale, it reacts to form calcium acetate, which is water-soluble, along with liquid water and carbon dioxide gas.
Ooh. Is that why you sometimes hear a faint fizzing sound when you descale?
That's exactly why. That's the CO2 off-gassing.
That is so cool.
Yeah, and the barkeeper's friend product relies on a different formulation, typically a blend involving citric or sulfamic acids, but the goal is identical. Break the solid rock into a soluble liquid and flush it away.
But here's where I'm genuinely stuck.
Okay, what's the holdup?
Why bother buying a specialized single-purpose cleaner like Barkeeper's Friend if cheap white vinegar does the exact same job?
It's a fair question.
Right, like you have to go out of your way to find it or wait for it to ship. Meanwhile, I have a massive jug of white vinegar sitting under my sink right now that costs me $3.
Yeah, almost everyone does.
If acetic acid does the exact same chemical teardown of the Limescale, it feels like a gimmick to buy the fancy stuff. And frankly, isn't running straight acid going to destroy the rubber seals inside the machine over time?
Okay, let's tackle the safety aspect first because it's a very valid concern.
Because I've heard that rumor forever.
Right. Decades ago, coffee makers used natural rubber gaskets that would degrade and crack when repeatedly exposed to acetic acid.
So it used to be true.
It did. But virtually all modern coffee makers use high-grade silicone tubing and gaskets specifically engineered to withstand wide pH fluctuations and extreme heat.
Oh, so they're built for it now.
Yeah, diluted vinegar is perfectly safe for the internal plumbing of any modern machine.
Okay, so if the internal silicone is safe, we're back to my original question.
All right.
Why buy the specialized barkeeper's friend descaler?
The video's creator addresses this directly, and it all comes down to the sensory reality of vapor pressure.
Vapor pressure.
Yeah. White vinegar is incredibly pungent.
Oh, that is an understatement.
Right. When you run it through a coffee maker, you are taking acetic acid and heating it to roughly 200 degrees Fahrenheit.
That sounds intense.
Heat drastically increases the vapor pressure of the acid, meaning it aerosolizes rapidly into the air. That distinct, aggressive, sour smell doesn't just stay in the kitchen, it permeates the entire house.
Oh, man. I know that exact smell. It's like you've decided to open a commercial cucumber pickling factory in your living room.
That's such a good way to describe it.
And the smell burrows into your clothes. You smell it for days.
Exactly. And for a huge portion of the population, that olfactory experience is a total deal breaker.
I can totally see that.
If you live in a small apartment or you have poor ventilation, boiling vinegar is genuinely overwhelming.
So what makes the specialized stuff different?
The barkeeper's friend formula uses acids that have a much lower vapor pressure. They don't aerosolize into the room when heated.
Oh, wow. So they break down the scale just as efficiently, but they remain completely odorless.
Yes. The creator recommends it simply because the best cleaning method is the one you will actually tolerate doing.
That makes total sense.
If the smell of boiling vinegar makes you skip descaling entirely, the specialty product is worth its weight in gold.
That's a great point. You have to engineer your habits around your own tolerance.
Exactly.
So let's say we've picked our weapon. We can't just pour this stuff directly into the tank undiluted, right?
No, definitely not.
The video is very precise about the ratios because we have to manage the concentration of the acid. Let's look at the vinegar route first.
Okay, so for standard white vinegar, the protocol is a strict 50-50 mix.
50-50.
Yep. You fill your coffee maker's freshwater reservoir exactly halfway with the vinegar. Then you fill the remaining 50% with cold tap water.
Why that specific ratio?
This specific dilution does two things. First, it ensures the acetic acid concentration is high enough to vigorously attack the limescale.
Okay.
Second, it provides enough sheer liquid volume for the water to act as a carrier, washing away the resulting calcium acetate as the reaction occurs.
Got it. So 50% vinegar, 50% cold water.
That's it.
But if you're sensitive to the smell and you bought the barkeeper's friend, you're not doing a 50-50 mix. That would probably be way too aggressive since it's a concentrated commercial cleaner.
Exactly. The chemistry of the commercial descaler is much more concentrated, so the ratio shifts dramatically.
What's the mix for that one?
The instructions specify an 8-to-1 ratio.
8-to-1.
Yeah. In practical terms, for most home coffee makers, you pour roughly 8 ounces of the barkeeper's friend cleaner directly into the empty freshwater tank.
Okay.
Then you fill the rest of the reservoir all the way to the max fill line with cold tap water.
Okay, so the machine is totally prepped, no stray coffee grounds, carafe is empty, and our acidic solution is loaded in the back.
We are ready to go.
We are officially ready for the main event, the descaling cycle.
Yes.
But the video splits the audience here. There's an easy way and a manual way, and it entirely depends on the microcontrollers inside your machine.
The easy way applies to newer, slightly more premium machines that feature a dedicated clean button.
So luxurious.
It is. If you have this feature, the machine's internal computer handles the entire kinetic process for you. You press the button, and it takes over.
What exactly is it doing behind the scenes?
It'll heat a small amount of the acid, pull it into the boiler, and then it will deliberately pause.
Oh, so it pauses on its own.
Yeah, it manages the contact time on its own, slowly pulsing the solution through the system over about 30 to 45 minutes to maximize the chemical breakdown of the scale.
It's the absolute dream. You push a button and walk away.
It really is.
But let's be real. A massive chunk of people listening are rocking a classic, indestructible drip coffee maker that has exactly one feature, a toggle switch that says on and off.
The old reliable.
Yes. If you have one of those, you're doing the manual way. You set the machine to brew the largest pot possible, and you flip the switch.
But this is the moment where people mess up.
You do not just let it run.
No, absolutely not.
The video emphasizes what we'll call the crucial pause.
This is the single most important mechanical step in the entire deep dive.
Really? The single most important.
Yes. If you're running this manually, you have to stand there and watch the freshwater reservoir.
Okay.
When you see the liquid level drop to exactly the halfway point, you reach over and you kill the power. You flip the switch off or pull the plug.
You're literally stopping the machine mid-brew while it's actively pulling water. Why?
Oh.
I know people who just run the vinegar straight through like a normal pot of coffee and wonder why their machine still tastes bad.
What's fascinating here is the kinetics of the chemical reaction.
The kinetics.
Chemical reactions are not instantaneous. They require contact time. Think about the thermodynamics we discussed earlier. The Limescale is baked onto the walls of the internal plumbing.
Right, the rock sweater.
Exactly. If you just run the machine normal, the hot acid rushes over the scale in a matter of seconds.
So it doesn't even have time to do anything.
It might dissolve a microscopic surface layer, but it washes straight out into the carafe before it has time to penetrate the rock.
It's like trying to wash dried paint off your driveway by throwing a single bucket of water at it.
That's a great comparison.
It just glides right over the surface without actually doing the work.
Precisely. By turning the power off halfway through, you trap that hot, highly concentrated acid directly inside the heating block and the internal silicone tubes.
So it's physically sitting inside the pipes.
Yes, the acid sits flush against the Limescale. The instructions mandate that you let it sit trapped in there for 15 to 20 minutes.
15 to 20 minutes.
During that entire window, the acid is actively bubbling, donating protons, and breaking the physical molecular bonds of the calcium carbonate. You are giving the kinetics time to work.
So if you skip this,
Without that 15 to 20 minute soak, you are quite literally flushing your time and money down the drain.
wow.
After the 20 minutes is up, you flip the switch back on and let the machine purge the rest of the solution out of the tank.
So it's all about forced contact time. You have to trap the medicine where the disease is.
Exactly.
And, while that acid is doing the heavy lifting and you've got this mandatory 20-minute window where you literally cannot touch the machine, it's actually the perfect time to handle other household maintenance you've been putting off.
Oh, absolutely.
For example, if you look down at your rug while standing in the kitchen, it's the perfect time to visit Kindic carpet cleaning on Google.
I mean, you're stuck in the kitchen anyway.
Seriously, you can't touch the coffee maker, so go book that carpet cleaning you've been avoiding. Knock out 2 chores at once.
It's excellent time management.
So your 20 minutes are up, you flip the switch back on, the machine sputters, hisses, and spits the remaining liquid into the carafe.
The final purge.
We've entered the phase I like to call the purge. And watching the source video, the gross out factor here is shocking. You don't expect it to look that bad.
The visual evidence is deeply validated.
So gross.
It really is. The creator notes that after just one single descaling cycle, they pulled an absolute ton of stuff out of the machine's interior.
A ton of stuff from a machine that we implicitly trust. We only ever pour pristine, clear tap water into the back of these things.
That is the grand illusion of clear water.
The grand delusion.
The calcium and magnesium ions are completely invisible to the naked eye when they flow out of your tap. They are dissolved.
Right.
But once they precipitate out under high heat, form rock, and are subsequently blasted apart by our hot acid soak, they flesh out in a highly concentrated, visible wave.
I think people look at the carafe after descaling and expect to see clear liquid, or maybe water with a slight coffee tint to it.
Yeah, they really don't know what's coming.
But the video highlights very specific visual cues that prove the chemistry worked.
Right.
You are looking for water that is densely cloudy, water that has turned a sickly yellow color.
Oh yeah, the yellow color.
And worst of all, actual weird, crusty flakes of matter physically floating in the liquid.
That's the rock. But wait, why is it yellow though? Calcium is white.
The yellow color is a fascinating intersection of chemistry.
Okay, hit me with the science.
You're right, calcium carbonate is white. But municipal tap water also contains trace amounts of iron and manganese.
Ah, metals.
Yes. As the limescale builds up over months or years, it traps those iron particles within the mineral matrix.
So the rock is holding on to the iron.
Precisely. When the acid dissolves the calcium wall, it releases that trapped iron, which rapidly oxidizes, essentially forming microscopic rust.
Rust in my coffee maker.
Yeah, that suspended rust, combined with the dissolved coffee oils that the acid managed to strip out, creates that toxic-looking, cloudy, yellow sludge in your carafe.
It looks like something you'd drain out of a car radiator, not a coffee maker.
It's pretty gnarly.
It's horrifying, but also Oddly satisfying because you know it's no longer inside your machine.
Better in the carafe than in your cup. Exactly.
Yeah.
But now we have a secondary problem. The Limescale is gone, but the entire internal plumbing system of the machine is now coated in either acetic acid or sulfamic acid, plus a layer of dislodged rust and mineral dust.
Which is not what you want to brew coffee with.
If you brew coffee now, it's going to be disastrous.
Which necessitates the rinse protocol.
The rinse protocol sounds official.
This is purely about mechanical flushing and dilution. You take that carafe full of yellow sludge, dump it down the sink, and thoroughly wash the carafe with soap and water.
Wash it good.
Then you fill your coffee maker's fresh water tank entirely to the top with cold, pure tap water. Nothing else. No chemicals.
Just pure water.
You run a complete, uninterrupted brew cycle. The clean water surges through the lines, picking up the lingering acid residues and the loose mineral flakes, sweeping them out into the carafe.
Okay, but what happens if you run that massive tank of pure water, the machine finishes, you hold the carafe up to the light, and the water still looks suspect?
It happens more often than you'd think.
Like, it's still carrying a faint yellow tint, or there's still a random flake floating around. Because my immediate instinct would be sheer panic. I'd assume I permanently ruined the internal boiler.
It's a very common anxiety, but the guidance from the video is explicit. Do not panic.
Okay, deep breath.
This is basic chemistry encountering saturation limits.
What does that mean?
If your machine had an extraordinarily thick layer of limescale, say you haven't cleaned it in 3 years, the first round of acid might have loosened more scale than the initial purge could carry away.
Oh, so it just couldn't flush it all at once?
Exactly. The solution is just brute force repetition.
Just do it again.
You dump the carafe, fill the reservoir with pure water again, and run another complete cycle. You repeat this mechanical flushing until the water in the carafe runs absolutely crystal clear.
How many times are we talking?
For heavily neglected machines, that might require 3 or 4 full tanks of water to achieve total dilution.
Wow. You just have to let the water do its job. Be patient. Flush it until it's pristine.
Pure persistence.
So we've successfully vanquished the chemical nightmare inside the boiler. The hidden plumbing is spotless. But we can't stop here, because the outside of a well-used coffee maker is usually a sticky, greasy disaster zone.
They get so dirty.
We have to tackle the exterior deep clean. But before anyone sprays a single drop of liquid on this appliance, the video issues a massive, non-negotiable safety warning.
It is paramount. The video creator readily admits that even they occasionally forget this step because of muscle memory.
I am guilty of this too.
Before you touch any exterior surface with a wet sponge or a cleaning spray, you must physically unplug the machine from the wall outlet.
It's dangerously easy to overlook. You're in the cleaning zone, you've got your spray bottle in one hand, your sponge in the other, and the machine is just sitting there in its usual spot on the counter, fully plugged in.
It's a recipe for disaster.
Why is it so dangerous?
We are about to introduce liquid cleaning solutions to the exterior casing of an unsealed electrical appliance. If liquid seeps through a seam in the plastic and bridges the gap on the internal control board or the primary wiring harness while the machine is live, you risk causing a dead short.
Oh, that sounds expensive.
At best, you permanently fry the machine's electronics. At worst, you create an arc flash and give yourself a severe electrical shock.
Yikes.
Pulling the plug breaks the circuit entirely. It is mandatory.
Always pull the plug. Never trust a switch.
Exactly.
Okay, so the power is isolated. The next phase the video demonstrates is the sink soak. You want to analyze your specific machine and identify every single piece that is designed to be detached.
Every manufacturer designs their machines differently, but you're universally looking for the glass carafe, the primary filter basket, the plastic lid to the filter housing if it's on a hinge that pops off, and potentially the water reservoir itself if you have a premium detachable model.
So grab all the loose parts.
You gather all of these modular components and move them to your kitchen sink.
And what's the specific chemistry we're employing in the sink? Because we aren't using the acid here, right?
Exactly. We switch tactics because the problem has changed.
Okay, what's the new problem?
Inside the machine, we fought alkaline minerals. Here, we are fighting hydrophobic lipids.
Right, the coffee oils.
You fill the sink with warm water and a standard grease-cutting dish soap. Coffee beans are inherently oily. Those oils, the caffeisol and kawale we discussed earlier, are hydrophobic, meaning they repel water.
They literally run away from it.
If you just rinse the plastic basket with water, the water slides right off the oil slick.
So soap is the answer.
Dish soap contains surfactants. These are ingenious molecules that have a hydrophilic, meaning water-loving head, and a hydrophobic, water-hating tail.
Okay,
The tails bury themselves into the coffee oils, and the heads bind to the warm water. They literally pull the oil off the plastic and suspend it in the water.
I love that. You just drop the parts in the sink, let the surfactants do the heavy lifting at the molecular level, and you can multitask.
Let the soap do the work.
Because while those parts are soaking, we pivot our attention back to the main body of the machine, which is covered in its own unique layers of grime.
It really is.
To tackle this, the video provides a very specific DIY spray recipe. In an empty spray bottle, you mix 1 cup of white vinegar, 1 cup of water, and about a single teaspoon of Dawn dish soap.
It's an exceptionally well-engineered, multi-purpose formula.
Really, just those 3 things.
The chemistry covers all bases. The white vinegar provides a mild concentration of acetic acid, which cuts through any hard water spots or mineral crusts left by evaporating steam on the outside of the machine.
Okay,
The water dilutes the acid so it doesn't degrade the plastic casing.
that's important.
And that teaspoon of Dawn dish soap introduces those crucial surfactants to break down the sticky, baked-on grease and airborne kitchen oils that inevitably coat countertop appliances.
It's a triple threat cleaner. Acid for the minerals, surfactants for the oils, water for dilution.
Exactly.
So we have our spray bottle. Where do we aim it? The video identifies 2 critical grime zones that suffer the most abuse.
Yes.
The first is the top of the machine, specifically the recessed area where you actually dump the coffee grounds in.
That area is an operational nightmare.
It's so bad.
Every single morning, when you violently shake a scoop of dry, static-charged coffee grounds into the basket, a small percentage inevitably misses and spills into the plastic hinges and crevices.
And you just ignore it because you haven't had your coffee yet.
Exactly. Then the machine starts brewing. Billowing hot steam rises from the basket, dampening those stray grounds, and essentially bakes them onto the plastic housing.
Wow.
Over months of repeated heating and cooling, it forms a crusty, gritty, dark cement.
It's exactly like cement. You try to wipe it away with a dry paper towel, and it shreds the towel. The grounds are fused to the plastic.
They really are.
You absolutely need to saturate that area with the DIY spray. The acetic acid and surfactants need time to soak into that crust and break the organic bonds.
You can't rush it.
But as gross as that top area gets, the second grime zone is exponentially worse. It's the heating pad at the very bottom.
The heating plate endures the most extreme thermal abuse of any component.
It gets so hot.
Consider the daily scenario. The machine is actively brewing, the metal plate is hovering around 300 degrees Fahrenheit, and you impatiently pull the carafe out to pour a quick cup.
We all do it. The mid-brew steel.
The drip valve hesitates, and 3 drops of fresh, hot coffee sizzle directly onto the bare metal plate.
Yes. And the water in those drops boils off instantly. What's left behind is the concentrated coffee solids, sugars, and oils.
That smell.
They hit that extreme heat and undergo a rapid Maillard reaction and caramelization. They burn.
They burn instantly.
And because that burn layer is inherently sticky, it acts like a dust magnet, catching every particle of flour, dust, and grease floating in your kitchen air. It transforms into this thick, textured, pitch-black nightmare of carbonized sludge.
To combat that highly specific carbonized sludge, the video introduces a specialized material science tool to pair with our DIY spray, a Scrub Mommy.
The Scrub Mommy. It sounds ridiculous, but it's brilliant.
It truly is an engineered marvel for this exact task.
For people who haven't seen one, what is it?
For those who haven't used one, it's a dual-sided sponge. One half is a highly absorbent hydrophilic foam for wiping,
That's a normal sponge side.
but the other half is made of a proprietary, temperature-controlled polymer foam.
Polymer foam.
Yes, this polymer has a very specific glass transition temperature. When you run it under warm water, it becomes soft and pliable like a regular sponge.
Okay.
But when you run it under cold water, the polymer structure rigidifies. It becomes extremely firm and abrasive.
So you spray that scorched, carbonized heating plate with your Vinegar Dawn mix, let the surfactants penetrate the burnt sugars, and then you take the cold, rock-hard side of the Scrub Mommy and go to town.
Exactly, you really scrub it.
Because it's a polymer and not steel wool, you can aggressively scour away the burnt carbon crust without permanently scratching the protective coating on the metal heating plate.
Exactly. It applies the perfect amount of sheer physical force to break the bond of the carbonized layer without damaging the substrate beneath it.
It's the perfect tool.
Once you've scoured the plate and wiped away the loosened, gritty cement from the top hinges, the machine genuinely looks factory new.
It's so satisfying.
However, the expert in the video issues one final critical warning before we can reassemble everything.
Right.
It's a final polishing step designed to prevent us from ruining tomorrow's coffee with our own cleaning chemicals.
Right, because we just sprayed a mixture of acetic acid and dish soap all over the top of the machine, dangerously close to the water dispersion head and the filter basket area.
You really don't want to drink that.
If we leave that residue there, we have a massive problem. The instruction is explicit. Any surface or internal ledge that comes into contact with the brewing process must be rigorously wiped down with a clean, damp microfiber towel.
The distinction between a paper towel and a microfiber towel here is scientific.
Oh, it's not just a preference.
No, a dry paper towel lacks the physical structure to pick up microscopic soap molecules. It merely smears them across the plastic.
Just pushing the soap around.
Exactly. A damp microfiber towel operates on capillary action. The microscopic synthetic fibers physically trap the dish soap surfactants and acetic acid molecules, lifting them away from the surface.
So it actually pulls it off.
If you lazily skip this step, the rising steam from tomorrow morning's brew will condense on that soapy residue, drip back down into your coffee grounds, and you will have successfully traded a funky hard water flavor for a horrifying, soapy, Dawn-flavored roast.
And nobody wants a soapy roast.
No one.
So we've neutralized the internal boiler chemistry, we've purged the iron oxide rust, we've used surfactants on the exterior, and we've utilized capillary action to remove the soap residue.
The main unit is pristine.
We just have to wrap things up with those components we left soaking in the sink.
That final phase is remarkably straightforward, but requires patience.
What's the trick?
The surfactants in the sink have already lifted the hydrophobic coffee oils off the carafe and filter basket. You simply give them a gentle wipe with a sponge, rinse them thoroughly under clean running water to wash away the suspended lipids, and then, crucially, you must allow all of those components to dry completely.
No putting wet pieces back into the machine.
None. You leave them on a drying rack or aggressively hand dry them with a clean towel.
Why is the drying so important?
Reassembling a machine with trapped moisture in the filter housing creates a dark, damp environment that is a perfect breeding ground for mold and bacteria.
Oh, that's disgusting.
Only when the carafe, lid, and basket are bone dry do you physically reinstall them onto the machine.
There is something so profoundly satisfying about that final reassembly.
There really are.
Sliding that perfectly transparent sparkling glass carafe onto a smooth, jet black heating plate. Dropping the pristine filter basket into place. It feels like you've reset the clock on the appliance.
It's like a brand new machine.
But stepping back from the coffee maker, this entire process leaves you with a deeply provocative thought.
It reframes how you look at water in your house entirely.
Exactly. If a simple coffee maker, an appliance we intrinsically trust, because we only ever feed it perfectly clear, supposedly clean tap water, can secretly harbor so much hidden, rock-hard, iron-stained, cloudy buildup that it physically alters the chemical extraction and taste of our drinks. What else is hiding in plain sight?
It makes you wonder.
What other daily use appliances in our kitchens are quietly suffocating under an unseen layer of hard water scale?
Think about the internal heating coils of your dishwasher.
Oh, wow, yes.
The bottom of your electric tea kettle, the internal plumbing of your refrigerator's water and ice dispenser.
I haven't cleaned my ice dispenser in, well, ever.
They are all subjected to the exact same thermodynamics and mineral precipitation. They're all just waiting for a deep chemical intervention.
It's an ongoing battle against chemistry. Anywhere water is heated or even just allowed to evaporate, minerals are being left behind, slowly building their rigid structures.
It's a never-ending war.
It's a never-ending war, but at least today we've learned the exact science of how to win the battle for our coffee makers. We've mastered the acids, the surfactants, and the thermodynamics to keep our morning brew pristine.
We have the tools now.
And speaking of keeping the essential things in your life pristine and well-maintained, here is your final reminder. Don't forget to visit Kinetic Carpet Cleaning on Google. Thank you for listening to the Best Way to Clean Your Coffee Maker podcast.